Okay. So the first thing that we're going to discuss today is about version 1 policy based site to site VPN without NAT. Okay. So without NAT means there will be no translating device. There will be no translating device. And what we will go today is we will go with NAT. So when we are using this thing, when there is no translating device in between, what will happen? The source port and destination port. What it will be? 500 for all 6 messages of the main mode. Okay. And when you will go with the NAT concept, so 4 messages, your message 1 to 4, they will use source port number as 500 and also destination port as 500. And then your message 5 onwards, it will switch to source port 4500 and destination port 4500. Okay. This is clear. Okay. So we will verify all these things. So first of all, let's go with the first part. Let me start the lab. And also I have shared with you guys the online lab access. Okay, remote lab access I have shared. So what you have to do, you have to make your entries, you have to book your slot 1 day prior, and you have to start your practice on the lab. Okay. If you are doing it in your own system, well and good. If you think you cannot do it, in that case, you can use the lab also. Okay. So this was our scenario. Let me start it. And in your drive, I have also shared one document that we created in the last session, right? The Word document. Let me share. This is the lab document I have shared, in which we have our lab image. Then how the configuration you will do that. First of all, you will do the basic configuration of your site A, site B, ISP, and then what we'll go for VPN configuration. And in the VPN configuration also, I have mentioned all the 5 steps. Okay. Then message captures also we have seen. Okay, so Wireshark captures, we take a screenshot and we have given here. Okay, so this thing I have shared. So you guys can refer to this also. And also this is the same thing that you can find in another document that is there in your drive. Okay. See here. In your drive, I have shared here this VPN theory. This is the theoretical part, not this one. So here also all the same captures are there. Okay. The first message, second message, everything is there. This is clear. All right. Now let's go and do the configurations. And also the configuration notepad also I have shared. You might have received it in the drive if you have checked. If not checked, then you will not find it. Simple, right? Okay. So first of all, let's take access of site A. Okay. This is site A, site B. Then we have ISP. So we already have the configurations, what we have done. Only message captures we need to understand. Okay. Do I need to explain anything in the 5 steps? Yes or no? See, this is the notepad I have shared with you, right? Now let me open the document that we created. In the basic configuration that in the site A, we are just configuring the host name and we are configuring IP addresses and a default route. Okay. And we have a loopback interface here, which is 10.1.1. Same thing we have done in the site 2 also. Okay. Then ISP. So in ISP, we will just configure the IP addresses. In this ISP, we have just configured what? IP addresses. We are not configuring any sort of routes here because your ISP is not going to have routes for the private networks. So now in this condition, when we will try to ping, so when you will ping from 11.1.1.1 to 12.1.1.2, in that case, you need to make sure that this connectivity should be there. This is the first thing to test, that your public to public connectivity should be there. Okay. Once your public to public connectivity is fine. Now, if you try to ping from 10.1.1.1 to 10.2.2.2, will you be able to ping? No, we will not be able to ping. Why? Because the ISP is going to drop the packet. ISP does not have routes for private networks, so ISP will drop it. Then after we will start our tunnel configuration. Okay. So in the tunnel configuration on the site A, we will configure the phase 1. In the phase 1, we will say that this is the hashing, this is the pre-shared authentication, and this is the DH group. Then after encryption algorithm is AES, and this is the lifetime. Okay. And also we will configure a key. That the key is what? Cisco. Okay. Now once phase 1 configuration is done, after that phase 2 configuration, so we will say crypto IP set, transform set, name we have given as T set, and encryption algorithm is AES, and hashing algorithm is SHA-256 HMAC. Okay. This is phase 2 configuration done. Then we have to select the tunnel traffic. That means, like I said, between policy-based and route-based, what is the difference? That in your policy-based VPN, ACLs will decide. Okay, in your policy-based VPN, ACLs will decide which traffic will pass through the VPN tunnel, right? So here we have created a ACL that when the traffic is going from source 10.1.1.1 to the host 10.2.2.2. This is the traffic that we want to pass through the tunnel. So we have created the access list to select the traffic. Now we have our phase 1, we have phase 2, and we have the traffic also. Now we need to combine everything. So to combine everything, what we will do? Crypto map we will create. So in the crypto map, I'm saying that this is my peer, and this is the phase 2 parameters, and this is the access list. Okay, and this I have applied it on the interface G0 by 0. The crypto map I have applied it where? On the interface G0 by 0, which is my outside interface. And same sort of configuration, we will do it on the side B also. So once we are done with these two configurations, now what will happen whenever you will start your ping from 10.1.1.1 to 10.2.2.2? First of all, phase 1 negotiation will be there. In the phase 1, right now we haven't mentioned here any mode, like we want to use aggressive mode or watch mode. So by default, it will be which mode? Main mode. Right now, this configuration is for main mode. Correct? We haven't mentioned here aggressive mode. So this is main mode configuration. And in the main mode, 6 messages will be exchanged. And then for phase 2, how many message exchange will be there? 3 messages. And phase 2 is known as what? Quick mode. Because right now we are going with the IKEv version 1. Okay, so phase 2 will be known as quick mode. And in the phase 1, we have main mode and aggressive mode. And right now we are using which mode? Main mode. Okay, all right. And after that, your entire data will be encrypted. And for encryption of your data, which algorithm will be used? For your encryption, AES algorithm will be used. And the carrier protocol will be what? ESP. This is clear? Okay. Now what? Let's go and do the packet capture because configurations are already there in the devices. Okay. Now let me check. First of all, show Crypto IKEv1. You can see right now I do not have my tunnel established. And here also you can verify. This is phase 1. And also I can say show Crypto IPsec assay for checking my phase 2. So in my phase 2 right now, I do not see any inbound ESP assays as well as outbound ESP assays. These two parameters right now I'm not able to see. That means even phase 2 negotiation is not there. And without phase 1, there is no possibility of phase 2. This is clear? Okay. So first of all, right now, if I will initiate the traffic, will I be able to ping from 10.1.1.1 to 10.2.2.2? No. Why? Why I will not be able to ping? These configurations, whatever I have shown you here, right? These all configurations are already done. Hmm? Yeah, tunnel is not there, but when I will ping from 10.1.1.1 to 10.2.2.2, tunnel negotiation should happen, right? VPN tunnel should be created. So I should be able to ping or not. In real scenarios, you will be able to ping, but right now you'll not be able to ping. Why? Because in EVNG, when you start a router, by default, the interface is in downstream. Okay. Small points, but you have to remember. So right now, if I try, see here, if I say ping 10.2.2.2 and source as 10.1.1.1, am I able to ping? No, I'll not be able to ping. Because we have to bring the interfaces up. We have to bring the interfaces up. Okay. So let's bring up the interfaces. And before bringing up the interfaces, let me go on the side B and let me capture the interface Z0 by 0. Okay, right now no traffic because the interfaces are in downstream. So first of all, let me go and bring the ISP interfaces up. On this thing also, I'll do it using Notepad only. Enable configuration terminal, interface Z0 by 0, no shut, interface Z0 by 1. Okay. Copy. Paste it here. Okay, now my interfaces are up. And since my interfaces are up, I should be able to see some traffic like ARP process and all. Okay, CDP, ARP, these kind of packets are traveling now. Okay. Now, first of all, what I'll do is I'll test my public to public connectivity. So public to public connectivity means what? That I will try to ping from 11.1.1.1 to 12.1.1.2. Okay. So I'll go on site A and I'll say ping 12.1.1.2. Able to ping. Let's see whether any tunnel was negotiated. No. Why tunnel was not negotiated? Hmm? No. The reason being that, see here, when we checked the phase 2 parameter, it is saying my local identity should be what? And my remote identity should be what? That means this should be the source, this should be the destination. Then only tunnel negotiation will be there. Okay, and that is the reason that right now my all traffic is from 11.1.1.1 to 12.1.1.2, and I'm able to see it. Okay. And even if I go and check on the site right now, show crypto IKEv1 essay, nothing, no turn up. Okay. Show crypto IKEv1 essay. So there are two ways you can verify. First thing that, see here, encapsulated packets, decapsulated packets, encrypted, decrypted, nothing, zero. Okay. And in the phase one, you can verify like this. And here you can verify using inbound ESP essay, outbound ESP essay. Okay. Now let me ping. I'll say ping 10222 source as. Okay. What if I ping 10222? Hmm? Why? Because it will be public to private. ISP will see this traffic, drop. Okay. So I have to mention the source 10111. Okay. Now my tunnel negotiation will be there. You will see I have 6 messages for mean mode and 3 messages for quick mode. And then this is my packets. These are, this ESP is what? My packets. And all packets are encapsulated and encrypted. So we will not be able to see anything here. This is clear. Okay. Now, and here, what is the carrier protocol? ISCAM. Okay. So first of all, message number 1 and 2 we will compare. Okay. So in message number 1 and 2, what are the things that are shared? What are the things shared in message number 1 and 2? Hmm? Hmm? Deputy Harman group, okay. Vendor ID, Haggle process, so okay. Then what else? First of all, we need to understand what are the parameters here. Okay. So the first parameter that is shared is your security association. Okay. Your essay is shared. In your essay, what will be shared? Haggle will be shared. Second, SPA parameters will be shared. Okay. And third is what? VID. Why VID? For NAT. Okay. They will show support for NAT. This is in the first message. And in the second message also, what will happen? Same things will be shown. Your security association, in which your Haggle is shared. Then SPA parameters will be there. And your vendor ID payload will be there, in which they will show the support for NAT. Okay. Now, if I talk about your security association, that is your Haggle parameters, where they will be available? They will be available. First of all, there will be a security association payload, right? In the security association payload, we will have proposal payload. Inside the proposal payload, we will have transform payload. So in the transform payload, your Haggle parameters will be available. Let's see. So first of all, we are verifying that, okay, from where to where the communication is. Okay. So the communication is from public to public. This is what everybody else will see, right? From source 11.1.1.1 to destination 12.1.1.2. What is the source port and destination port? 500. Protocol IKEv1, Internet Security Association and Key Management Protocol. Then after, see here, the SPI parameters. Okay. So in the SPI parameters, in the masses one, what will happen? Your initiator SPI will be there. And this SPI is randomly calculated for every single security association. That means every Haggle parameter combination you create, every ISACAM policy you create, for that there will be a SPI. Right? Now, this is the initiator. Who is this guy? Initiator. The site A is what? Your initiator. So in the first message only there will be initiator SPI. There is no idea about responder, so we don't know what is the responder SPI. Okay. And if you see here, this is coming as a reply. This is coming as a reply. Okay. And again, the reply is also using the source port, destination port as same only. Correct. And here if we see the SPIs, so here we have initiator SPI also, as well as the responder SPI also. Because this time we know that who is the responder. Okay. And just make sure that this is your message number one. This is man mode message number one. And this is mean mode message number two. Here. So this side, it is the initiator, and this side is the responder. This is clear so far? Okay. Now, if I see that my Haggle parameters will be available in the security association proposal and transform. So let's see step by step. Now here, exchange type. Sorry, first of all, next payload is what? If we check here, what is the next payload? Okay. The next payload is security association. So if I check this security association payload here, let's expand it. Inside this, we will have another payload. Here it says next payload is what? Vendor ID. But here one payload we have in the security association. What is the payload? Proposal. Okay. So this is our proposal payload. Okay. And inside the proposal payload, if we check, so we have transform payloads. You can see transform 1 and transform 2. Why? Because in the last session, when we were configuring this, so we created two different security associations, right? So here we can see that there are two proposal payloads, right? Sorry, two transform payloads, 1 and 2. If you expand the first one, these are the Haggle parameters for the first one. These are the Haggle parameters for first one. And then here we have our vendor ID payload, which is negotiation of NAT. That means showing support for NAT. This is clear. Okay. Same thing we can check. So this side here, it is sending two transforms. One is this Haggle parameters, and another one is also there, which is about MD5. Okay. So the initiator is sending here two different security associations, two different set of algorithms that, okay, I can support MD5 with some other algorithms, and I can support AES with some other parameters. So the responder is going to do what? Out of these two, okay, out of these two, like, security association 1 and 2, it will select an appropriate single one, right? So here also we have the security association payload. And inside the security association payload, you can see we have the proposal payload. Okay. So this proposal payload, if we expand, okay, this one, if we expand, we will find the transform payload. And here the transform payload is how much? 1 only. Why? Because out of multiple, this guy will select only one. And here we have all the Haggle parameters. And after the Haggle parameters, we do have the vendor ID payload for negotiation of NAT. This is clear. This is the message number 1 and 2. So here we have SPI parameters, we have vendor ID payloads, and we have security association being exchanged. This is clear. Okay. Now let's go for the message number 3 and 4. Okay. So here, if you check right now, the two payloads that it was sharing. Now here you can see this is like 3-dash encryption algorithm, MD5 hashing algorithm, DH group is 5, right? So like this, it is sharing. So out of these two, your responder has selected 1. Responder has selected how many? 1. Okay. Then let's come to message number 3 and 4. This is message number 3. Bring it this side. And message number 4, bring it this side. Okay. So now this side, this is what? Your main mode, message number 3. And this side, this is your main mode, message number 4. Okay. So in the main mode, message number 3, what are the parameters being exchanged? One is there will be key exchange, that is Diffie-Hellman key will be exchanged. So key exchange will happen along with the nonce payload and NAT D, NAT discovery. Earlier, we were just in the message number 1 and 2, they were just saying that, okay, I support NAT-T. The other device, other side is also saying that, okay, I also support NAT-T. Now, this time they will check, is there any translating device available or not? So for checking, for discovering the translating device, what do we have? NAT-D payload. Okay. Same things will be here also. Okay. And now we already know that this side, this guy is what? Initiator already decided. And this guy is the responder who has been already decided. Okay. So let's expand them. Okay. So again, we have the same initiator SPA and responder SPA as we were having in the second message exchange. Same thing is here. Okay. Then after here, what is the next payload? Key exchange. That means this will be what? The Diffie-Hellman key exchange. Okay. So if we expand the key exchange payloads, see here, we have the key exchange payloads. This is the payload for key exchange. This is also the payload for key exchange. So here what is happening? Your Diffie-Hellman keys are exchanged. And Diffie-Hellman keys are exchanged along with your nonce value, right? So we have here a nonce payload also, you can see. We have a nonce payload also. So whatever the nonce value is being shared, okay, here they shared 10. So that is the same value we are going to have. The responder is also going to give the same value. Okay. So this is your nonce payload, second one. This is clear. Okay. And key exchange payload we have seen, nonce payload we have seen. Now NAT-D, NAT discovery. So how the NAT discovery will be done? So we have here separate NAT-D payloads. Okay. So if we see here, one is for the source, another one is for the destination. Here also for the source and for the destination. Okay. So if we check here, like this is the hash value that we talk about. Okay. which is calculated based on source IP, source port, destination IP, destination port. Okay. And this is the destination here. And this is the destination here. Now for a normal request reply, we see that source will become destination, destination will become source. That means hash values also should have the same feature. So if we go and check here, okay, if we go and check here, this is the source part. So this should become destination here. And here, this one is the source. So this is the, here, this is the source, this is the destination. So this cross is completing. Source is becoming destination, destination is becoming source. So if it is proper, that means there is no translation in between, right? We simply say if the hash values are same, that means there is no translating device no translation device in between. Okay. So between site A and site B, there is no translation happening at all. Okay. So this is your message number 3 and 4. Clear? Okay. Now let's come to message number 5 and 6. Here the keys have been already exchanged. So in the message number 5 and 6, all the messages will be encrypted. So we will not be able to see anything there, right? So let's go for it. Message number 5 and message number 6. Okay. Now here, this is main mode, message number 5. And this one is main mode, message number 6. Okay. Now, in the message number 5, what will be exchanged? Identification and authentication. Okay. So here, what will happen is identity and authentication. Same thing here. We will have identity and authentication. But since these are what? Encrypted, you can see, first of all, you can verify the initiator SPA and responder SPA. Okay. And this is the initiator and responder SPA. This is the initiator and responder SPA in the same flow. Okay. So next payload is what? About identification. Here also we have identification payload, but everything is what? Encrypted. So we won't be able to see anything here. Okay. But in the identity payload, what will happen? The IP addresses of the peer will be sent. Like site 1 will send its own IP address to the site 2, and site 2 will send its own IP address to site 1. And they will authenticate each other. Clear? Okay. And you should always remember in the phase 1, your message ID will be what? Always 0. In the phase 1, message ID will always be 0. Okay. All right. So let's clear everything. Then you can check the quick mode also. So in the quick mode also, everything will be encrypted. You won't be able to see anything. Okay. But in these 3 messages, what will happen? In these 3 messages, remember we configured the transform set, we configured the encryption algorithm, we configured the hashing algorithm. those parameters will be exchanged. Okay, so if I show you that, this one, see here in the phase two quick mode. So first of all, your essay proposal, we configured like ESP with AES, AS. These things will be shared. Then they will share one key and a non-spelling. Okay, same thing. Responder will agree on the things. Same like with phase one. Okay, site one will say I'll use AES algorithm with ESP and SHA-256 with ESP, right? So site two will say, okay, I will agree on these parameters, and they will again exchange a key. And then after what they will do? They will start doing the exchange. So third message is all about confirmation on that. Okay, confirm. And phase two will be established. Okay. So phase one purpose is what? To propose how the IPsec essay will protect the data traffic. And phase two purpose is what? To agree on the IPsec essay parameters. And then third is to finalize the quick mode exchange, that okay, the quick mode has been successfully established. Okay. And then after this, your ESP protocol will take up the data from source to destination. This is clear? Okay. So this was the concept without NAT. Now let's see how does it differ from a concept that is having NAT in between. That means there is a translation device in between. Okay. So let's go for it. Let's close it. And also let's close all of this. Stop all notes. Close the lab. This one is I version 1, site to site policy list. Site to site without NAT. Okay. This is our first lab. Didn't save the name. I version 1, site to site without NAT. Okay, so I'll just clone this lab so that all the names and everything, we don't have to write everything again. And this will be with NAT. Say, okay. This is the lab. Open. Now in this lab only, we will make a slight modification. Okay. Site A is here, but this router, between this router and ISP, we will have a firewall, which will be doing the translation. Okay. So this connection. This ASA will do what? Translation. So if ASA will do the translation, the public IP will be available on ASA, and this side we will have a private network. Okay, so let's consider here we will use 172.16.1.1. This side on the ASA we can use 1.long. And here this side is now. Okay. this sort of network we are designing. So from ASA Z0 by 0 interface, I'll keep on the inside, and Z0 by 1 interface, I'll keep it on the outside. Long, long. Okay, so this side also we are using /24 only on the 172 network. This is how our lab is going to look like. So here I have 12112. And the tunnel will be established between again site A router and site B router. Okay. This is where the tunnel will be established. That means we are not establishing the tunnel from ASA to site B. We are establishing again from site A to site B. But on the site A side, we have a firewall device that is going to do the translation. Okay. So now what kind of translation will be done here? The translation will be that you want to translate this IP, because when according to site A, what will be the peer IP? 172.16. Like self IP will be 1.1 and peer IP will be, right, 12.2. So let's go for it. This IP, I want to translate it to which IP? Consider 100.1.1. Okay, static translation. Why? Because we want bidirectional communication. Okay. All right. So this is the translation that we are going to perform. Now let's go for it. Basic configurations. Now let's take the configurations also copy. We have one. Basic configurations. Side A side. Okay, let me copy one configuration. Because these are very basic configurations. Now see here on the site A, hostname will be site A, interface gig 0/0. This IP will change. This will be what? 172.16. Loopback is there, and this will also change. This will be 1.law. This is clear. Okay. On the site B side, is there any change? Interface gig 0/0, 12.1.1.2, loopback 10.2.2.2. No change. And route also fine, because from ISP, I mean from site B, your route will go to the 12.1.1.2, right? Okay. ISP, any change? No change. So right now this configuration is okay. Now let's go for the ASA configuration also, right? So here only I'll do, let's do it again. ASA configuration, enable configuration terminal, Then first of all, hosting, I'll call it ASA1, or just call it AS interface gig0/0. Then name is inside. Okay. Then IP address 1.11.255.255.255.0. Then no shutdown, and same configuration for the interface we will copy. Okay. So interface gig0/1. This will be outside 11.1.1. This is fine. Okay. Now your ASA also has to forward the traffic towards whom? Towards the ISP. So we will give a route. How do you give a route on ASA? You cannot say IP route. How do you give a route? How many of you have done ASA? 1, 2, not done. Online? Okay. If not done, then understand. Route. Then you will give the interface name. So which interface it is? What is the name of the interface? Name. We have given the outside name. So you will say outside. Okay. Now, same way. Destination is what? Like 0.0.0.0. This is how you give default. So you don't need to give all the zeros. You can give 1 0 and it will consider entire network ID 0. Same way for the subnet also 0. Now, next stop address 1111. This is clear. Okay. Now, like we said, we have to translate this IP also. So how do you give translation? Object, directly name, object, network, and you give a name. Okay, so first of all, let's give it for a public IP. This is my public IP. Host. What is the public IP? No, this is the translated IP. Okay, so rather than this, let me write it like this, translated IP. Otherwise, you'll get confused. This is how you will give it. Then after, create a new object. Object, network. That means right click on the button. Site A, outside IP. Oh, let me see. Okay, you can use a name that is you find more relevant, okay, as per your understanding. So what is the outside private IP? What I'm saying here, site A outside private IP. This is site A outside private IP is which one? According to ASA. According to site A, this is the network you're protecting and this is the outside. Okay. This is clear. Then you will say NAT from where to where? Inside to outside. Okay. And you're performing what? Static NAT. And your static mapping is with the translated. This is done. That means automatically this IP will get translated to this side. This is clear. Okay. Now this much configuration is enough. So let's go and paste all these configurations. First of all, we need to bring all these to the system. So let's take an access. First of all, site A. In the configuration form I have mentioned site A, B, ISP, ASA. Site B, ISP, ASA. Now, now, now copy site A configuration first. Site B configuration. Then ISP configuration. And then ASA configuration. So NAT, we can verify the translation from here. Inside to outside. Your site A outside private IP will be translated to the translated IP. More details you want to see, show NAT detail. So this IP 172.16.1.1 will get translated to 100.1.1. Okay, this is okay. Here everything is good. This was unchanged. Site A 1.1 and 10.1.1. Show interface IP brief. Z0 by 0 1.11, 11.1.11, and this side the route IP is okay. Fine. So we have done the basic configuration. Now, first thing I need to check is what? That from my site A, the connectivity to ASA. This one thing I need to check. Okay, let's go and test. So from site A, I will try to ping gateway. I'll say ping 172.16.1.11. Success. Second thing I need to test that ASA will be responsible for providing public to public communication. So from ASA to site to public IP, I should be able to communicate. Let's verify. So if I say ping 12.1.1.2, able to ping. So that means my entire communication is fine from here to here. Now, right now, if I will try to ping from my site A to site B, will I be able to ping? Let's check. Ping 12.1.1.2. So on my site A, I have a route, no problem, default route here, also default route here, also default route. Everything should be good. But everything is not good. Why? Think about it. Private network. Hmm? We are already translating it to public IP. So there is no chance of having private network now. And until this site A to site B connectivity is not there, problem is there. Which inspection? ICMP. Okay. Okay. Except protocol ICMP. Now inspection is there. No communication. Why? First of all, think whether request is getting blocked or reply is getting blocked. Okay. On the site to B, what I'll do, I'll go and capture some. I'll start debugging. Okay. Debug IP ICMP. Now see, if I'm trying to ping from here, site B is sending the reply. What is the problem? And see, there is no private IP concept. Is here. Where? For what? We have already allowed ICMP inspection. Hmm. Hmm. So inside to outside, this is going. Yes. Huh? Which one? Yes. Why? Why? Because outside to inside is not permitted, but we are initiating the traffic from where? That means my traffic is going from inside to outside. ICMP inspection has started. That means reply ICMP should also be permitted. Correct. What is the problem here? Correct. Where the response will be blocked. ASA is doing the translation, no problem. ASA to here connectivity is there, not an issue. Okay, let me show you something. No, ICMP reply ASA will not block. If inspection is there, that means reply traffic will not be blocked. See here. Let's go to ISP. Oh, we have configured translation means what? Both things will happen, translation and untranslation. Okay, that is not a problem here. What is the problem? Understand here. Here I have started debugging on the ISP. Now let's go and generate the same traffic again. Do you see something is happening on the ISP also? Let's see what is happening on the ISP. Okay, let me generate this traffic again once. Understand it. And this is site B. Debug can give you a lot of information. First of all, site B. So we can verify site B sending a reply. Okay. But it is also getting one message. Okay, see here, it's also getting one message. From where it is getting? Who is 12.1.1.10? ISP. right? See here, what ISP says that there is a packet coming, IP packet. Source is this IP 12112, your site B. Destination is what? And what it says? Unroutable. Why unroutable? Because does your ISP know how to reach 100.111? Not default route, static route. On ISPs, we cannot give default route, right? So here what will happen? That we will give a static route from ISP to ASP. For which IP? For this IP. Yes. Because the reply will come. See, when the request is going, source is what? 100.111. And when routing is there, we don't check the source. Routing is done based on the destination IP address. So request is going here. And this guy is also replying to 100.111. But when the reply will come, who is the destination? 100.111. ISP will check its routing table. How do I reach? So that is the reason that here we have to give a route. Is that clear to everyone? Yes. Okay. So let's go on the ISP and give a route. This is ISP. Stop all debugging. And here also no debugging. Okay, let us see. Stop all the debugging. On the ISP, we will give a route. Static route I will give. So I'll say IP route. I want to reach 100.1.1.1. And since it is single IP address, 4 times 255. And what is the gateway? 11. Done. Now. Oh, sorry, 11. Not even 10. ASA outside IP address is 11. Yes. 11.1.1. 11. Okay, so this is the route we will have to give. Okay. Yeah, but that will require proxy. Okay, so we cannot take that risk. Okay. In real scenarios, you will be configuring what fully specified. That means you will give exit interface as well as the IP address. Okay, now let me check whether I'm able to ping or not. Now I got this connectivity. So now there should be no problem. That means from here to here connectivity is there. Now normally like we configure IPsec, same way we will configure IPsec. This is clear? Okay. Now see here. On the site A, we will configure the Haggle parameters first. What if I don't configure Haggle parameters? Like if I don't configure phase 1, what will happen? If I don't configure Haggle, will I have VPN tunnel setup or not? Why? I will have or not? Think about it. If I don't configure phase 1. Hmm? To running config exception and supply. Okay. To show crypto ISACAM default. Policy. see something here. Preference. We'll keep it small. See how many essays are defined already. See, so many essays are defined. So if I don't want to configure, I can just go and use any of these. Any of these policies I can use, and you can see they are already having the priority numbers 65,507, 8, okay, 9, 10, 11, 12, 13. And same way, site 2 will also have the same. So all I need to mention is what that I will want to use a default policy. Key we will configure. Key we are going to configure. I was talking about SAM, haggle parameters. So those are already there. Is that clear? And when we will configure, these are the default one. When we configure, so that SA will be given the priority. Is that clear? So if you want, you can use these ones, or if you want, you can create your manual ones. Is that clear? Okay. Now let's go and configure. Keep it small. Now see, crypto, ISACAM, then policy. We give a number. Priority number we will give, let's say 10. Okay. Then haggle parameters, hashing we want to use. Which one we should use? At least 256 we should go, or else 384 or 512, that is your choice. So let's say SHA 256 we will go. Okay. Authentication, we share we will do. Group 14 at least. Encryption, AES, lifetime, even if we will not give default, it will take 24 hours. Okay, so if you want to give, you can give also. If you don't want to give also, it's fine. Okay, that is totally fine. This is given. Haggle parameters done. Exit from here now. Next step. Key, out, crypto, ISACAM, key, 0 we will use, and any key we can use. So let's use Cisco. Then, first of all, you will write the keyword address. And then we have to give here a peer IP address. So for site A, who will be the peer? Because I want to establish my tunnel here. So 12.1.1.2. 12.1.1.2. This is fine. Okay. That's it. Okay. See done. Now IPsec phase 2 we will configure. How do we configure? Directly access this. Transform set we have to give, right? So crypto, IPsec, transform set, let's give an E, P set, then algorithms, ESP, AES, ESP, chart 256. This is clear. Exit from here. Next, access list we will give. Okay, 100. Format. Protocol also you will give, right? IP 10.1.1.1. First of all, host you have to write, right? Host 10.1.1.1 to the host 222. Fine. Okay. Then combine everything. Again, exit. We will say crypto map, CMAP. Then we have to give a number. Let's give it 10. Then, okay, we already have that. Why? Could not find a crypto map entry CMAP 10 to modify. Crypto map CMAP question mark. Okay, let's use 100. Wait a minute. To running. To map. We have to give a word CMAP. Give a number. IPsec. ISecond. This we have to give. Okay. Now read it. Now who will be the peer for site 1? Peer will be 12.1.1.2. So access set peer equals to 12.1.1.2. Then set transform set. What is the transform set name? T set. Okay. Then address ACL name 100. This is clear. Step 4 is done. Now what? Step 5 applied on the interface. Which interface we will apply? Z0 by 0. Interface Z0 by 0. And we will say crypto map C map. This is clear. And you can see ISA campus on. Okay, so here now everything looks good. Was there any change in the configuration? Like if you check this configuration, the VPN configuration that we did earlier, any change in this? Not visible. Any change here? No. In the key also no change. Transform set also no change. Tunnel traffic also no change. Then crypto map also no change. How do you apply the crypto map also? No change. As it is, let's copy this. Okay. And we are creating a new notepad for this. So let me just this is site A configuration, right? And this is what? VPN configuration. Clear? Okay. So in the site A configuration, no change. That means in the site B also there will be not really a very big change. Okay. So what will be the change? Let's see. If I paste it. Okay. Check the configuration. This is for site B. Here any change? In this part, no change. Key? Yes. Address will change. What will be the address? Hmm? If you give 172.16.1.1, why 11? We are not establishing tunnel with here. We are establishing tunnel with site A. So you cannot use this IP. You cannot use this IP. Yes. The IP will be what? 100.1.1. Okay. So here what I'll give 100.1.1.1. All right. Then transform set any change? No. Tunnel traffic any change? No. Source will become destination. Destination will become source. Okay. Then crypto map here will change 100.1.1.1, and then we will apply it on the interface. Okay. Let's copy this configuration for site B, and this is site B. Paste it. IKEv is on. Now, first of all, if I try to initiate a tunnel setup, okay, so will I be able to initiate a tunnel setup or not? Hmm? Think about it. Hmm? Everything is there. Shall we start initiating? Okay. So let's say, since we have given the interesting traffic, so 10.2.2.2 source as 10.1.1.1, right? Let's check. Show crypto IKEv first. Yes, terminal is active, right? And if I check show crypto IPsec asset, you see I have inbound and outbound ESPSA, and you can see here packets encapsulated, decapsulated, everything is there, right? So our VPN configuration is okay. Now here we will capture the packets and we will see the NAT D, NAT discovery. Okay. Terminal, first, let me clear. So both pages I want to clear. So I'll say clear crypto sessions. So check show crypto IKEv essay. So you can see this is deleted. Okay. Now let me go and capture the packets on the site. Okay. And from here, let me initiate the tunnel set. Okay. So these are the ESP packets. Here we have 6 messages from main mode, 3 messages from quit mode. Okay. And you can see the IP address here is 100.1.1 and here it is 12.1.1.2. So if we first of all compare the message number 1 and 2, okay. This is a situation when we are using what NAT. In mode message number 1, condition is NAT is there. And this is the main mode message number 2, and here NAT is. So first of all, verify the source and destination. Source IP, destination IP, source IP, destination IP. Here we also know that this side is the what? Initiator, and this side is the respondent. So your site 2 is the respondent. Okay. What is the source port and destination port? So since this is message number 1 and 2, here only NAT traversal will be negotiated. That they will show the support for NAT T. Okay. Now expand it. Expand it. Same things we can see here. Initiator SPI is there in the message number 1, responder SPI is 0. In the second message, responder SPI will also be there. Then we also know that here we have the security association payload. Here also security association payload is there. In the security association payload, they will have what? Security association, that is proposal payload will be there. But in the proposal payload, transform, in the transform, security association. Okay. So we can check this. Okay. So now if you see here, okay, if we expand the proposal payload, so here we have the transform payloads, right? And we expand the transform payload. So in the transform payload, we will find our Haggle. This is the Haggle. Same thing here. And this is the vendor ID payload, which is showing support for NAT. Here also, this is showing support for NAT. So this is same with, what we had earlier. Because actual NAT discovery will happen where? Third and fourth masses. Okay. So let's go and check it. Go for masses number 3 and 4. Masses number 3. Message number 4 also same. Message number 3. Message number 4. Now here you will understand actual NAT discovery. So this is main mode, message number 3. Okay. With NAT and on the site main mode, message number 4 with NAT. Now again here also we can check the source IP, destination IP, correct? Source IP, destination IP, correct. Source port, destination port, right now it is 500. Right now it is 500. Okay. Now expand it. The SPIs are there. The SPI parameter is there. Then after SPI parameters, your key exchange payload will be there. So we can see the key exchange payload is also there. Correct. Then after with the keys, a nonce value is also shared. So the nonce payload is there. Okay. And for NATD, we have 2 hash values for source and destination. Same here, source and destination. Okay. So now here, whatever is the source is supposed to become destination. And here, whatever the destination is supposed to become source here. Okay. So if I check here, okay, if I check here, my source here, is it same with the destination? But is my destination here is same with the source? Is it same? No. This is not same. This one is not same. This one is same. This time hash values are mismatching. And since the hash values are mismatching, it means there is a translation device. And if there is a translation device, now what should happen? Port should change to 4500. So when you will see the message number 5 in the message, see the messages are encrypted. So this time we will not be able to see the messages. That means the data inside the message we cannot see, but we will be able to see the port numbers. Okay. So let's check it. This is the message number 5. Do you see the port number here? The port number is what? 4500. This is clear? Okay. And if I check message number 6, here also 4500. Now entire communication will happen over port number 4500. Okay. Then later on these messages also everything over 4500. And then ESP also over port number 4500. Okay. Understood? With the NAT T, what will happen? 2-3 things you have to take care of. One is there should be a route on your ISP for the translated IP address. This is one thing you need to take care. Second thing, your ICMP inspection. Okay, what if I turn off ICMP inspection? Is it? Let's check. By default, let's see. Let's go to ASA. I'll say no fixed protocol, ICMP. So if I check show running policy map, is there any ICMP inspection? Do you see? No. Let's see whether I'm able to ping or not. Why? Because this is VPN traffic. This is VPN traffic. This is tunnel traffic and it is traveling over UDP. And UDP inspection is already there. Understood? Yes, TCP and UDP inspection is by default present. Understood? Those who have not done ASA, they will face a little bit problem here. Okay. That's why your routing and some ASA and these things will be required. ASA will be there in this concept, your NAT concept. Again, after this, it will be there in the overlapping VPN. Okay. And in one more concept, it will be there. 2-3 concepts it is there. Okay. This is clear? Okay. Now I have another question. Okay. First of all, let's go and let me see clear crypto sessions. Clear crypto session. So right now, no tunnel. I can check show crypto IKEv1 passive, it is deleted. And if I check show crypto IKEv1 passive, okay, clear. All right. Now tell me one thing. If I try to establish the tunnel from side B, will my tunnel get established on? If I try to ping from 10.2.2.2 to 10.1.1.1, will I be able to ping or not? Yes. Well, When I ping from, see, if I go on site A, if I ping from 10.1.1.1 to 10.2.2.2, I'm able to ping. But now I'm saying that I don't want to ping from 10.1.1.1 to 2.2.2. I want to do the reverse thing. I want to ping from 10.2.2.2 to 10.1.1. Will I be able to ping or not? Don't know. Okay, but ASA is done, right? Or in normal routing switching also, you might have studied if you are pinging from source to destination, then destination is also pinging the source. Hmm. Why? Exact. Right now, when I'm initiating the tunnel setup from site A to site B, direction of traffic is what? This. So it is going on the ASA inside to outside. So in ASA, inside to outside or high security to lower security, everything is permitted. And by default, TCP UDP inspection is there. So your reply traffic will also be allowed. But when you're initiating the traffic from here itself, it is coming from lower to higher, and lower to higher, nothing is permitted. What we need to use? ACL. So here on the ASA, we will create a ACL. Okay, what will be the ACL? That is also interesting. What should be the ACL? Okay, okay. Just give me one moment. Let me go on the firewall itself and let's do it. Because here also there is one more concept of ASA included. Yes. Mhm. Let's say out to in, then directly IP. You don't want to give the action? Permit, ICMP, host. So I don't know what to do. You tell me. IP. Okay. Should I give IP? If I will give IP, then everybody will be able to come from outside to inside. Or this guy 10.2.2.2, he can use anything. But I just want to allow tunnel traffic. TCP or UDP? UDP. Okay. First of all, let's try to establish the tunnel so that you can be sure that tunnel is not getting established. So if I say ping 10.1.1.1 from the source 10.2.2.2, so my tunnel will not be established here. Okay. Now, since it is not getting established, we have to allow this traffic. Okay. Now, host. Okay. Enter. Okay. Access group out to in inbound interface out. Should I be able to ping? Traffic is coming from outside to inside, right? So very well applied. This is a policy-based VPN. You don't create a tunnel interface here. The ACL will be applied on the outside interface only because the traffic will hit on the outside interface. So now should I be able to ping or not? Maybe. Okay. No, we are not able to ping. Not getting. Problem is not with the site one. Problem is there with your access list. What is the problem? What is your destination in the access list? Translate the IP. Okay, let's say 100.1.1. This is your saying, right? So ASA knowledge will be tested with this. Done. Still no tunnel establishment. Why? Hmm? What? Think about it. Hmm? Which IP address? 10.1.1.1? Huh. Why you guys are not understanding? This is the traffic that will pass inside the tunnel. 10.2.2.2, 10.1.1.1. But when ASA will receive the packet, from whom ASA will receive it? See here. No. Let's say when the replies are coming. So who public IP communications are there, right? So first of all, who will be the source? Source IP is going to be the public IP. So that means this is going to be the source. Who will be the source? This IP here. This is the source. Okay, fine. Now let's come to the destination. Now what should be the destination? If you say this, now remember ASA is packet flow. When ASA receives a packet on an interface, first of all, it will check existing connection, no existing connection. It will try to establish a connection. After that, what it will check, ACL or translation? Is it? ASA will first check the translation. So if you give 100.1.1.1, ASA will translate it to 172.16.1.1. Then after it will check ACL. Now in your ACL, you are giving an entry what? You are giving source as this, destination as this. But your destination address has been already translated. Your traffic will not match the ACL. So in your ACL, source should be 12.1.1.2 and destination should be 1.1. Multiple concepts will be used here. Understood? What vice versa? No vice versa here. Okay. Here your source will be this 12.1.1.2 and destination will be 1.1. Clear? Yes, untranslated. Why? Because in ASA, first of all, your translation will be checked, and then after your ACL will be checked. Understood? Now, see here. No access list output in, let's say, show running access list. This is the access list that is running right now. Now check this. We will see. Now let's just paste this one over. See, this is your access list. Let's remove this, extend it. Permit UDP from host 12.1.1.2 and destination should be 172.16.1.1. Okay. Now, if you allow entire UDP, that also is a problem. Right now it will work, no problem. You can see here. Okay, that's right. Okay, I didn't apply it. I just created the ACL. Access group, out to in, inbound, interface, outside. Now let's check. Right? Now we are able to establish the tunnel also. But the thing is, right now I have allowed entire UDP protocol, but I just want to allow tunnel traffic. So when I just want to allow tunnel traffic, this will not be my ACL. My ACL will be port number equals to 500, port number equals to 4500 in case NAT is there. Only these two specific traffics I will allow. Yes. Yes. Just give me one moment. So NAT means if NAT will be there, the traffic will hit on port number initial 4 packets. Why you are forgetting? Initial 4 packets will be what? Traveling over the port number 500. IKEv1 will be there. So with the help of IKEv1, what they will do, they will discover whether a translating device is there or not. So those 4 messages will be traveling over the port number 500. And in the message number 3 and 4, it will be discovered that your NAT device is there in between. So automatically your traffic will switch to port number 4500. So if any of these two port number, if you miss, your tunnel will not be established. And since we don't want to allow entire UDP traffic, we will allow only port number 500 and 4500. And since we have given this, now you can easily establish the tunnel. Let me see clear. Crypto stations. And again, try. I should be able to ping again. Okay. And you can verify my tunnel negotiation is there. These are all my ESP packets. This is my phase 1. This is phase 2. So you can verify here. Port number up till message number 4, we were using the port number 500. But message 5 onwards, port number 4500. So this is how your entire communication will be there. So now it should be clear to you, okay, that how you create a policy-based site-to-site VPN without NAT as well as with NAT. So when you're configuring with NAT, like I said, few things you need to take care of. What are the things? One is you must give a route on the ISP towards the ASA, but for which IP? Your translated IP for this IP. Okay. Second thing, you need to give an access list on the ASA if you are initiating the tunnel from site B to site A. And third thing, here on the site B, your peer address should be what? 100.111. On the site B, when you will give the peer address, when you will give this peer address, so peer address should be public IP because tunnel will be established using public IP only. This is clear? Online people? See, VPN practicals, you will have to do it every single day. If you think today's practical you will do tomorrow there will be a new practical. Now, almost every day, we will not have theory. We will have practicals, direct practicals. Okay. So complete all your labs. And I gave you a task, but the video was not there. So it's okay. Today, you have to do the task. When you will be going without NAT. Okay, this one is with the NAT. Let me modify this. This is with the NAT. Okay. So when you're going without NAT, transmission device will not be there. In that case, what you will try to do, one thing you will use is that establish the tunnel and change the access list. Change the access list. Like right now, what is the access list we are giving? Access list 100, permit IP host this to this. Change it to access list permit IP host from 10.222 to 10.333, something like this. That means try to change the access list and see whether your tunnel is getting affected or not. Not there. That means any random IP address. We are just considering the case that by mistake you have done something wrong. This could be 10.112 also. If by mistake you're doing, or 10.111, you might do it. Okay. So if you're doing something like this, what will be the outcome and how you will fix it? Okay. Second thing you will try is that you have established the tunnel. You are able to ping from 10.111 to 10.112. Your access list is also okay. But go and change this key on one of the site and then check that whether your communication is getting interrupted or not. Okay. So these kind of things, when you will try, what will happen? You will get to know that if you're getting certain type of error, what you have to check actually. Troubleshooting. That you will understand with this. Understood? Okay, then that's it for the day. I'll see you guys tomorrow. Have a good day. Notepad, yeah, Notepad, everything I'll upload.